Okay, looks like we're live on YouTube. Let me share my screen. Okay. Wait, this feels very strange. Okay, I suppose, can people still hear me? I think my display just changed.
I can still hear you.
Okay, that's good. I guess, yeah, because we didn't really use Zoom before, so it's kind of a foreign experience. Yeah, let's get started. And as usual, we just go through and get the update from what people have been working on. Yeah, so start with Michael again. Yeah, what is progress on your side?
So I got the version shard chunk header changes merged at the end of last week. So now I'm moving on to getting the post phase one branch merged. I've rebased onto the version header changes.
Oh, yeah, I think you cut out for a while.
Oh, yes, sorry. It says my connection is unstable. I just said there's a couple Python tests that are failing in Nadec right now, so I'm going to debug those.
I see. But like otherwise is already rebased, like
yeah. The rebase like, was easy. Yeah.
I see. Okay. Yeah, I mean, I think it's great that we get to the end of the issue with version shard chunk header, and I think it's also great that we fix them. And we take our time, but yeah, it's great that the test has actually caused some problem and we fix them. So yeah,
for
it's
sure.
good. Yeah. See, Piotr, what about you?
Okay. Can you hear me?
Yep.
Okay, so basically I finished working on the first version of the tools that I can use to debug the memory. So I wrote basically the proxy allocator for Rust and also for C. So this allows me to see, basically annotate all the allocations that happen on the C code and include also the stack trace. And I also wrote my own custom tool, which allows me to dump the memory of a process and then compare it and see exactly where the memory leak is happening. I also spent some time investigating on how to do it, how to dump the process memory, how to do it in a safe way without actually stopping the process and without there were a couple of issues, and also how to recover the symbols. So how you can do the, so that right now I have a tool that allows me to basically see where each pointer was allocated. Sorry, each memory chunk was allocated, and right now I started the node, and I see like first memory stats. So one thing that I first noticed is that the memory reporting for the RocksDB is wrong, and they don't report the accurate data at all. And I see that they report like let's say 3 times less memory than they actually use. So let's see if I can find it. Well, so like for example, right now they report 768 megabytes use, and we see 1.5 gigabyte actually being used.
I see.
Before it was 3 times. Right now, that's twice as much. Before it was 3 times as much. So they are apparently not measuring it correctly, and I see exactly where those allocations are happening.
I see.
On the code. So there are basically three places that are the biggest ones.
I see. What I mean, other than RocksDB, what about other? Is there other noticeable large allocations?
I mean, other than that, we also see that the C memory is fragmented. So also, for example, right now the memory usage is at 2.8 gigabytes. The C code uses 1.56. And then also I see that 500 megabytes is also used by C code in the region that was just not released. So there is a huge memory fragmentation as
I
well.
see.
So basically, so that's like 2 gigabytes total.
I see.
2 gigabytes total is for the C.
I see.
I mean, C including the.
Yeah, I understand. Yeah.
And then, and the rest in the Rust code, I see we use right now 500 megabytes. So that's increasing slowly. And I mean, I saw a couple of times like a lot of huge spikes created in the Rust code. For example, when the messages are coming, and then at one point the deserializer was using like a lot of memory, and there was like huge 2 gigabytes.
Yeah, actually, I don't. Yeah, I think that's not coming from messages. That's deserializing the Genesis file, most likely.
No, it's not the Genesis file. When the deserializing the Genesis file happens, it happens at exactly different times. Because
I see. Okay.
Then I see when I start the node, then I see that a different function. Basically, I see that the from config method from the Genesis is being used, and then it happens that then I know that this is Genesis.
I see.
Right now, I see that this is the memory. Basically, in this case, the memory was used by the chain network, and it was basically a different library. But then afterwards, the issue fixed itself, and the memory went back to normal. But then there were a couple of other times where I saw the spikes happening in a different place. So, for example, once the messages got actually deserialized, then now a lot of memory started being used, for example, by Actix at that point. And basically the Vue client was slow to process the messages. It was processing them slowly, and there were a lot of different messages just being stuck in some of the queues.
Interesting. So how much?
It went up to, let's say, 6 or 7 gigabytes, and then it started going down slowly. It took like 10 minutes to go down, and eventually everything finished. But there were a lot of messages, basically, a lot of different types, and even responses that took just a while. That took a lot of memory, but that was like a spike, not a memory leak.
I see.
I mean, there might be some still memory, some small memory leak somewhere in the Rust code, but this is also just a separate thing.
I see. Okay. I mean, yeah. So it seems like most of the memory allocations in the C code does come from RocksDB, and
I mean, this is those are like the only allocations pretty much that I see from the C code. I just don't see any other allocations. Like I don't see any allocations, for example, from Wasmer at all. It probably must mean that it's clearing all the memory after it finishes running.
Yeah.
That's why I don't really see any.
That sounds good. Allocation. Yeah. So is your node actually synced, or is it still syncing?
I mean, the node should be synced.
I see.
Let's see if I can check the stat. Well, right now it says it's downloading blocks.
Okay, yeah, so it's not yet synced. Okay.
I mean, it was synced before, and now it became back, went back to the state where it's downloading blocks. So I'm sure maybe it's the node became too slow after I added my own debugging. Maybe now it's too slow because of that.
Did you build with release or did you build with debug?
I did build it with the release, but then also added the debug equals true to other symbols.
I see. But yeah, maybe maybe something you add the debugging to cause it to slow down so that it cannot keep up with the speed of the network. Maybe.
Anyway, it's possible to just get it to work faster.
Yeah, sure, yeah. Okay, yeah, I think it sounds good. We can.
There should be some way. I'm just not sure how a good node is supposed to work. What is it supposed to actually show?
Yeah, sure. We can take this offline, and we can work through it. Okay, yeah, I think that sounds good. Looks like we're making more progress. We just need to make sure the node can actually sync, and then once it's synced, it's probably 2.8 definitely sounds low. Like I mean, on testnet we see much larger memory usage, like maybe even up to like 10 gigabytes. So yeah.
I see, but is it like a spike or is it like a constant?
No, it's a gradual increase. But I think there might have been some spikes in between, but yeah, I mean it's overall not.
Well, so far I see that just the memory in the RocksDB keeps increasing. So it was.
Yeah, we can see how I mean, whether it just like keeps going without without even being released.
I saw that it went up. Let's see how much did it go up. The C usage. Well, in this case, it went up by 100 megabytes in like 2 hours or 3 hours. But then a few hours ago, it was like at 800, like 8 hours ago.
I see. Okay, sounds good. Yeah. Okay. Misha, are you here?
Yes.
Yeah. What have you been working on?
I'm working on StateSync.
Okay. What's specifically about StateSync?
So I opened a couple new issues. It's the original task of combining state park without extra memory usage. But I'm also making it more robust.
I see.
Yeah, but I'm also going to finish that issue with Orphan Attack.
Yeah. Okay.
I'll do that first.
Okay. Yeah, I think for StateSync, something there could also something there could also be adjusted. It seems that currently the timeout is there's timeout of 10 seconds, and I think we are actually sending. It could be too not enough, and we're actually sending more requests than necessary. But yeah, I think you can also maybe look into that. But yeah, I think sounds good. Okay, sync. Okay, so So Alex has been working on, well, he's not here, but he has been working on rewriting syncing code, mostly with implementing like client sync and garbage collecting headers. Okay. Yeah, I guess I can still share this part. How do I get a whiteboard? Okay. Has anyone used whiteboard in Vim? Is it good?
I think Alex was using it the other day and it was not working very well.
Well, I think that's just Ubuntu not working very well, I guess.
No, fair enough.
Let me try. Can everyone see this? Is it?
Yeah.
Okay. Yeah. So I wanted to discuss something about block and the chunk producer selection. I think as you may all know, we're going to first we're going to do we're going to enable sharding through. Okay, it doesn't. Okay, it works well on Mac. So we're going to go we're going to go into sharding with this kind of simple nightshade approach where we have block producers and block producers will track all the shards, and let's just keep moving. But and they produce blocks, and they're also responsible for the data availability stuff. And we will also, for the decentralization of the network, we'll also introduce separate chunk producers who will not be block producers and whose responsibility will be solely to produce chunks in the shards. Now comes the interesting question of how are we going to choose them? And I have some ideas, and what I want to why? So this thing feels very weird. I cannot edit the what? So once you write down something, you cannot edit it? This is okay, whatever. Let's deal with it. So there will be definitely more chunk producers than block producers. Let's say we have 100 block producers, and let's see, we have I don't know. We don't actually know the number. Just okay, 3,000 probably too much. Let's say we have 300 chunk producers. So the idea is that we kind of want to treat them separately because I mean, like, let's say we have 8 or like 16 shards. If you want to track every shard, your hardware requirements will definitely be higher. And if you're just producing chunks in a single shard, pretty much your hardware requirement would be same or even lower than what we have today. And that makes difference for validators, right? Like before they even go in and validate, they need to know that whether my machine is capable of doing the job that I'm going to do. So naturally, for block producers, they need to have much more expensive hardware, and for chunk producers, it's they can just have normal hardware. And therefore, the proposal is that we can, when people stake, they actually signal explicitly whether they want to become block producers or they want to become chunk producers. And the way we're going to select them is basically the following. For block producers, it works the same way as, well, it basically works the same way as today. Well, not exactly, with modifications, but basically we just take the block producer proposals and we just take the top 100 of them. And I think this is a change from today's threshold proof of stake. But I think that we have already discussed long ago, and I think we all agree that we can, do this change to switch to just taking the top 100 proposals. And I think Michael even write down the exact algorithm for mapping block producers to the heights in the epoch. And for the chunk producers, this is where it becomes more interesting, because block producers, since they track all shards, they naturally have the capability of producing chunks. And I mean, it's so that well, I guess I'll just go with what proposal I have, and then we can discuss it whether it makes sense. So the idea is that for chunk producers, we just combine all the proposals from block producers and chunk producers, and we just take the first 400 of them, and there could be fewer, but that's the idea. And then one important thing that I have not mentioned is that rewards, right? So today, rewards are distributed to the block or chunk producers according to their stake and uptime. So basically, today, your validator's reward is their validator stake divided by total stake times uptime, and times reward, epoch total reward. And with this separation of block producers and chunk producers, the proposal is that we have 50% of the reward going to block producers, and the rest goes to chunk producers. So this way, basically the goal we want to achieve is that there should be a balance between block producers and chunk producers, so that people cannot easily take advantage of becoming either one of them, and there will not be a centralization of stake. It will not be the case that simply because block producers has more stake, their fraction is larger, then people all go and delegate to them, and then they make more rewards. So you kind of want to have, the idea is kind of want to balance the per capita return, becoming both a block producer and or becoming a chunk producer. And you also don't want people to take advantage of that to become chunk producer with a lot of stake, and then they earn a lot of rewards by avoiding to become a block producer to run with more expensive hardware. And yeah, I think I probably talked too much here. Is there any questions so far?
So I'm not sure if for chunk producer selection, block producers should be included.
Mm-hmm.
Because block producers will probably have more stake. And if we are still selecting at a frequency proportional to stake, then block producers will be selected more often. So there's still, I guess, some minor centralization there. I think the top 100 should always be block producers, and then the next 300 after that should be chunk producers with no overlap.
I see. So you're saying block producers will not be chunk producers?
Yes.
I
know that has some disadvantages, right? Because there's if you are a block producer and a chunk producer at some height, then you're sort of guaranteeing that chunk will be in the block. Whereas if they're all external, then we might either have to increase the block time, or deal with occasional missing chunks because they didn't arrive on time. But I think this is sort of the fundamental trade-off, right? Is that if we're choosing to allow block producers to be somewhat centralized relative to chunk producers, then we have to, I guess, allow for the possibility that the chunk producers will be less performant, and so sometimes blocks will be missing chunks.
Right. So yeah, I think one of the concern here is that I think what you said, yeah, I mean that is kind of a concern, I would say, but I wouldn't. I don't think that's even the kind of the crux of the problem, because so basically what we want is that like we want so well, yeah, I mean obviously there are some constraints for like chunk producers, right? So for example, we want that each shard have some minimum number of chunk producers, right? And the code cannot be too small. For example, if every shard only has one chunk producers, then like it's kind of a problem, because if they're just offline, then like it's basically for the entirety of the epoch, no chunk will be produced for that shard, and the shard essentially just stalls, and we don't want that to happen. So we probably want a minimum of like, I don't know, like 5 or maybe even like 10 chunk producers per shard. And I think the problem like that comes with that is, what if there are not actually that many chunk producers, like people, there are not that many people who want to become chunk producers at some point, because so today basically this problem doesn't exist, because there's you can there's only one pool, and you can like everyone goes into the same pool, so that it's not a case where like you have like an abundance of block producers but you don't have chunk producers. But whereas in this setting, I mean, it's actually possible that that there will be like there may be abundance of block producers, not necessarily abundance, but there will be like let's say like 50 or like 40 block producers, but no one actually signaling to become chunk producers, because like to do that you actually send a different transaction, and like it's not that you just like right, like it's not that you can just sending one transaction and becoming both, right? So I mean under what Michael's proposed. So I think that is actually the bigger problem, and I think actually I originally had the same idea, and I discussed with Alex, and I think he made a good point, is that like you do not want to have some like special case to deal with the case where there's not enough chunk producers, and you have to like say, oh, if there's not enough chunk producers, let's just let's just spill over some of the block producers to also become chunk producers, so that we don't get into this scenario where a shard only has like 2 chunk producers, for example. Yeah, so I think that's more. Yeah, I think that's the major concern here.
Right. Okay. Yeah, that's an interesting point. So is the main reason why we want chunk producer staking to be different from block producer staking is so that someone with a low hardware doesn't accidentally become a block producer?
Yes. Yes. Yeah. So actually I should probably elaborate on that. So there is obviously a difference in hardware requirement, and this is actually what drives all of these changes, right? So basically, a chunk producer cannot become a block producer. Well, assuming they're not running expensive hardware, and if they do, yeah, they obviously can be both, right? But assuming they're just running normal hardware, or like what we pretty much the requirement we have today, then the idea is that chunk producers cannot become block producers, because they will not. If they do, that's quite problematic, because not only they will not be able to keep up with the network and like miss blocks, the network will also suffer from this, because pretty much they're just attacking the network by not being able to keep up with it. So to make the kind of hardware requirements, so to make this more like predictable, the idea is that each chunk producer is only responsible for one shard, and yeah, and only one shard. Basically the idea is that there's no surprise, right? It's not that you suddenly just become responsible for multiple shards, where like your requirement hardware is only capable of producing tracking tracking one shard, and we ask you to track like 5 shards, for example, and that will cause problems. So yeah, I think the kind of motivation is to make it easy for validators to address, and also just to improve the decentralization of the network, because we can have a lot of chunk producers. I mean, 300 is just random number here. We can probably have even more if we have more shards.
Yeah, presumably the chunk producer limit should somehow be proportional to the number of shards.
Yes.
So I was sort of operating under the assumption that because chunk producers have less hardware, they also have less stake. But I guess that's not inherently true in this model. Like it could somehow be the case that.
Yes, that's actually a very interesting point, right? So basically the like one of the interesting case that you kind of, why is this okay? Yeah, this whiteboard is weird. So one of the interesting case that we need to consider is that what if like someone stakes a town just to become a chunk producer, hoping to maximize reward while running on cheap hardware, right? So it's something we want to avoid. And yeah, there are some sorry, oh, sorry, Mike, are you talking? It's like if you were like, yeah, your connection is very unstable. Hello? Okay, I guess Michael dropped out. Well, I mean, anyways, we can continue the discussion without Michael, I guess. Yeah, so basically I was saying that the situation we want to avoid is that someone just stakes a lot, or they somehow attracted a ton of stake to become a chunk producer, and now they're running on cheap hardware, and they want to maximize their rewards. Okay, looks like Michael is back. So Michael, did you want to say something before you dropped out, or was someone else talking? I didn't.
Well, my question is also here, like, I mean, right now we need to have some kind of protection. Like, what if someone becomes a check producer and his hardware doesn't, for example, work at all, or he does something malicious, right? It should be like the behavior should be similar to if he's running, let's say, to situation if he were to run on the cheap hardware, he cannot keep up with being a check producer, right?
Sorry, I don't understand your concern. Like, are you saying that?
My point is, like, do we have currently like any kind of logic that can slash chunk producers that don't actually work?
Oh, we don't. Yeah. I mean, we don't like slash them per se. But what we do is that if they don't keep up, they will just get kicked out. They were basically, if their online rate is less than like 90%, they just get kicked out and they don't get any reward. It's not an implicit form of slashing, but depending on how you view it, right? If basically if they expect to get reward and they don't get it, then whether that's slashing, you can interpret it differently. But yeah, basically the idea is that yeah, if you cannot keep up, then yeah, you just don't get any reward, and you would be kicked out from the active set of validators.
I see, but then it might be also a valid strategy to become a chunk producer for a short period of time. Even if you cannot keep up, if you just get paid immediately without any delay.
Not necessarily. So, well, depending on what you mean, right? If you say you cannot keep up with the network, so basically the reward is computed at the end of epoch, right? If you cannot keep up with the network, presumably in this epoch, your uptime is less than the threshold. And if your uptime is less than the threshold, you don't get any reward. Like you'll just be kicked out and without getting any reward.
Oh, I see.
So,
I see.
yeah.
The reward is basically at the end of the epoch. Okay, that makes sense.
Yes.
So that works.
Yep. Yeah. So Michael, I think you wanted to say something before you dropped out, but I think your connection was. Yeah.
Yeah. Sorry about that. I was just saying about the concern you've written there with chunk producers running large stake on cheap hardware. That wouldn't be possible under a model where the top, X become block producers and the rest become chunk producers or something like this.
Yes. Yes. So I see your idea. So basically, you're saying that even if they stake for to become chunk producers, if their stake is so large, they just somehow like they're forced to become block producer.
Yeah, I think under that model, we couldn't really have two different queues. Like you would have to know sort of roughly what the block producer stake cutoff is, and be careful not to stake too much if your hardware is too low. Which isn't great. Like I understand that's.
So that's an interesting idea. Although the drawback is also so basically the drawbacks is that people can, let's say you're just an honest honest chunk producer doing your own business, right? You run a node and then you have some staking pool that people can stake to you. Now suddenly some malicious attack comes in. They have, let's say they have like large stake. They just stake to you, and suddenly they bump you into into this realm of block producers, and if we do what you propose, they're forced to become block producers, and then they effectively will just be kicked out, and this is just like a way to attack them effectively.
Yeah, that's an interesting point. Something else that occurred to me while you were just having the conversation about chunk producers getting kicked out for low uptime. Is uptime measured as chunks included in blocks? And if so, then does that mean that block producers could choose to censor certain chunk producers that they don't like?
Yes, it's I think it's the other way around, right? Exactly, because it is measured as chunk including blocks. So if they censor, they don't get it doesn't really decrease the well, I think it hurts slightly, but I mean, I think overall, like it's kind of like your expected number of chunks also don't increase, right? So,
I meant like if there's a colluding set of block producers who are trying to make sure that only their friends are chunk producers, then whenever they get a chunk from someone outside of their clique, they just don't include it in the block, even if it was
right. But then their expected number of chunks also don't increase. So
okay, I see. Yeah, block producers get punished as well. So it's not a free attack. It's like a griefing attack, right? Because they take some hit as well because.
No, so well, I think my point is that if like you're chunk producers and your chunk is not included in some block, then so basically for that blocks, there's no increase in expected blocks, expected chunks produced. So basically that just gets skipped. And when we calculate your expected number of chunks that you produce, we only calculate from the blocks where your chunk is included.
Oh, I guess I don't understand how that works then. So if I am legitimately offline, how do we know that I'm legitimately
offline? Yeah. So in that. Oh wait. Yes, in that okay, I think I misspoke about something. Yes, I think okay, I think what you said is correct. Like yes, the block producers they can avoid to yeah, they can just like censor yes, they can censor blocks from chunks from chunk producers. Although from another perspective, so they don't have a very clear incentive to do that because presumably when you include more chunks, you earn more reward from the transaction fees. And if you do not include them, then those you're like effective. You're kind of losing, like you yourself also lose something, right? So it's not like a
right. It's not free. It's some kind of griefing attack.
And, yes.
Yeah. Okay.
Yes.
So it's not obvious under what conditions one should do this. Okay. Cool.
Yes.
Makes sense. But yeah, so going back to what we were talking about, the attack where someone stakes a whole bunch to push a chunk producer into block producer is pretty interesting, and yeah, I'm not sure what to do about that.
Yeah, that's why. Yeah, that's why we want to have the separate pool, right? So that's kind of to mitigate this attack. I think the original idea was to, as you suggested, we just like put everyone's proposal together. And we pull like we just take the top like 50 or top 100 whatever to become block producer, and then and then we realize there's this possible attack, and that's why we say we want to have this different pool. And okay, so I guess I'll just describe some of my ideas on how we want to approach this problem. So the problem is that if someone just stakes a ton and becomes chunk producer, and like they kind of getting more reward on cheap hardware, it's not a unsolvable problem. Some ideas to mitigate this is that one thing is depending on how many shards we have, right? If we have a lot of shards, we can say a chunk producer's reward is kind of it's basically what the proportion. It's proportional to the. It can be calculated not instead from the overall reward, it's calculated from the shard reward. Like let's say like we divide the reward into each shard equally, and then within the shard you calculate the reward based on stake or based on the number of chunks you produce. And there, if there's a sufficient large number of shards, it becomes less of a problem. Let's say we have even if we have only 16 shards, you're like capped. Your reward is capped at around 3% of the overall reward. So basically, even if you stake more, it will not kind of some of your reward will just be wasted. And if you have adjust this to the onto the block producers, it means that if you have more than 6% of the total stake, it's better for you to just become a block producer. And otherwise, you're just wasting a stake. You just have some stake for which you don't earn rewards. And to take this idea a bit further, something I was thinking about is that we can say that a chunk producer cannot earn more than 50% of the reward of this shard or something like that. And basically, their reward is capped at something like 50% of this shard. And therefore, even if they stake more, they actually they just have a diminishing return on their stake. And yeah, that's some of the ideas I had. I don't know what people think about it.
I think that there is a problem that if you cap rewards or stake, then some of those chunk producers can try to split their stake among multiple accounts, so they can try to circumvent any caps this way. And I think good system should be resistant to this. Like it should be not be possible to get more rewards by splitting your stake in any way.
Yeah, I think that's a good point. Although I mean, I would say that if you split your stake, means like you have to run more nodes, and it does also cost you more. But
I think you can modify your node to use just one node to validate, to produce blocks or chunks for multiple accounts because I think especially for block producers, much of computation, like pretty much all of computation, can be shared, like not have to be duplicated. For chunk producers, you'll have to track more shards, but I think it still would be beneficial if you want to participate in a network as multiple chunk producers to have one node modified to track all the necessary shards, but still share as much as storage and computation as possible.
Yeah. So what do you suggest, Evgeny?
Well, my idea, I think that the reward per stake should never be more for chunk producer than for a block producer. So it doesn't make sense because it's like there are less hardware requirements to be a chunk producer than a block producer. So one of the constraints is that the rate of rewards to stake for block producer should be greater than or equal to that for chunk producer. And then we can, but it could be less for chunk producer, and we can use this if there are too many chunk producers. So for example, we may cap the total fraction of reward that gets to chunk producers. So for example, we say that no more than 50% of all rewards go to chunk producers. So if there are more than 50% of all stake is by chunk producers, they can get proportionally less rewards, so that they get 50% of all overall reward. This would incentivize block producers because it would incentivize to stake as block producer. Then we can have two kinds of staking. One kind of staking that can be used by both block producers and so when someone stakes, they can specify either they want to be either block producer or chunk producers, or they can only want to be chunk producers. So in the latter case, they will not be chosen as a block producers. In the former case, they can be chosen as a block producer, and they would probably prefer to be block producer because this would earn them more reward.
So it's your idea that chunk producers can get less than 50% of the reward, and then the rest will whatever is left will go to block producers.
Well, if chunk producers have less stake and they have less hardware requirements, it kind of makes sense that they earn less.
So basically, it's your proposal that the reward is basically chunk producer reward would be their total stake divided by the overall stake.
Yes, however, we can have a limit, like if it's more than 50%.
Capped at 50%.
Capped at 50% of overall. Yes, I think that makes sense. Like provides incentives if they hit this cap, then it incentivizes to to have more block producers, and we want this probably. And if it's less than 50%, then it's proportional to their stakes, so they can stake either way. But block producers, well, we may need to incentivize Well, but I think in this case we have more than 50% of block producers, so we don't need to incentivize more block producers in this situation. And chunk producers are incentivized because they don't need as much hardware resources, so it's more efficient to be chunk producers. So all incentives are proper in this
Yeah, that sounds like a good idea. Yep. Yeah, thanks, Evgeny, for pointing this out. Yeah, so as a next step, I will write a post on on our discourse channel first, and we will invite validators to join the discussion as well. And I think after some discussion, that we can consolidate this in a NAP. And
well, I have also a question. I have a question about a few things that you mentioned. So basically, you mentioned that you can declare yourself as being either only chunk producer or chunk producer and a block producer, right?
Yeah, I mean, I think that,
I think that if you want to be a block producer, you can be also chunk producer, but not the opposite.
Yes.
But my point is, wouldn't it be better to make those things separate? So if you declare yourself to be block producer,
you can
only be block producer, and if you declare yourself as a chunk producer, you can only be chunk producer. That way you will avoid running into this issue that, let's say, you declare that you can be both, but you are being chosen as chunk producer, but you don't know that your hardware is not good enough, and then you get surprised.
No, so the idea is that block producers, their hardware can always run. They can always be chunk producers, right? So I think your suggestion of doing the strict separation is kind of is similar to what Michael mentioned. The downside of that is that, like, you can have a block producer who stakes a lot, but because there are a lot of other people who stakes more than them, they don't become a block producer, but their stake is more than sufficient to become a chunk producer, and it's quite suboptimal if they just get nothing.
What I wanted to consider is, would it be possible to have, let's say you have a tokens that you can stake, and what if you could let's say you have X tokens and you could do staking that you could stake for block producers, and the same amount could also be separately staked for the chunk producer. That way you would be intensified to whatever tokens you have, you would have to distribute it into two places, right? And now the advantage of this would be that it will be always optimal for you if you have to run both, a separate machine from block producing and separate machine from chunk producing, because you are earning the money from both sides.
But then, like, you know, if you then like the problem is, like, sure, I mean, you can stake for both, right? Nothing.
I mean, my point,
like, you can just split your stake and, like, yeah, but like the thing is, like, if you are just running, I mean, one thing is it requires you to run more machines, right? Another is that if you're already a block producer, like, your machine can just, like, run for, like, it doesn't make sense for you to having to run additional machine just to become a chunk producer, right?
Well, I think I didn't express it correctly. My point is, I wanted to consider, would it be possible to basically allow staking the same tokens for two purposes? You stake it
I see, you want to stake
for blocking, and then you can stake the same amount of tokens for chunks, and you completely separate the staking for block and chunk producing, and you create, like, two independent systems.
Well, that's it seems to me that would be a much invasive change. And,
I mean, I understand this would be a more invasive change, but the advantage is that now it's always optimal. I mean, now you don't need to really compete whenever it's better to run a block producing.
Oh, so you're saying that you kind of always
it's always right now it's always optimal to earn money from both sides.
But does it mean you will have, like, two accounts, basically, like, because you, like, or, like, will you actually have one account that somehow become both chunk block producer and chunk producer. Maybe you want one account to. Okay, I guess yeah. Maybe that's. I kind of okay. I think I kind of get what you mean. Like you.
I mean, this was
okay,
like just a general idea of doing this separation.
Okay,
so basically,
I think yeah, we can take this offline and discuss.
It's more like a general idea. I don't know the technical details to say exactly how that should be implemented. It's just from the point of if I were, let's say, a Blonk or a chunk producers, then right now my understanding is that right now I would have to work just keep it in order to maximize my income. Given that I have some stake, I would have to decide would it be better to be block producer or a chunk producer.
Okay,
right?
so we're actually running out of time, unfortunately, and we definitely can take this discussion offline. I'll ping in the chat when I write up the post, and please do comment, and then we can continue the discussion there. And thanks everyone for participating, and this is great discussion.